This problem states that the second law of thermodynamics asserts that when two dissimilar gases are mixed, entropy is generated. We're going to demonstrate this by using the binary PG mixture model to show that 1 kilogram of hydrogen and 1 kilogram of carbon dioxide mixed together at the same pressure and temperature, 100 kPa and 300 Kelvin, will result in an entropy increase. So we're going to go to Test Calcs, System States, and then the PG model, and then the test app. Alright, so we know that it is H2 and CO2, so we'll just change that up in the right for our fluids. And then the first gas is pure hydrogen, so we will go to the mass fraction and enter that as 1, showing that it's pure hydrogen. And then we'll enter that the pressure was 100 kPa and temperature is 300 Kelvin. We know that the mass is 1 kilogram, and that should be enough information to get the rest of our thermodynamic properties. Right? And then the next fluid was pure CO2. So the mass fraction of fluid A will be 0, showing that it's pure CO2. Again, the mass is 1 kilogram. And then it says it's the same pressure and temperature. So we could either type in 100 kPa and 300 Kelvin again, but it's easier to just change it to equals P1 and equals T1. And then that's all of our information we need. And so the mixture is going to have a mass of mass 1 and mass 2. It says the pressure and temperature are the same. And we know that the mass fraction of A is going to be the mass of hydrogen, or mass 1, divided by the new total mass. So M1 plus M2. Right, and that should be all the information. We get the rest of our properties. So now we can go to the I/O panel to calculate the energy difference. You could do this a few different ways. You could do it all in one line. I like to do it in a few separate lines just to keep it organized. So I would say S initial gets the mass of mass 1 times the specific entropy of state 1 plus the mass of 2 times the specific entropy of state 2. So that's the initial mass. I hit enter, or you can hit calculate, and then scroll down here in the output area, and there's the initial entropy of the two separate mixtures, or two separate flows. And then S final will be mass 3 times the specific entropy of state 3. So that's of the mixture. Again, hit calculate, scroll to the bottom, and there you go. You can see that it obviously increased, but we were asked to solve for the difference, so I'm going to do ds equals S fin minus S initial. Scroll all the way down in the output area, and you get that the entropy increased by 0.775. Right, and then the next part of the question says, what if the second gas were helium instead? So that's an easy change. Just go back to the state panels, go back to state 1, and change fluid B to helium. Calculate, super calculate, and it's not working yet, but it should be in future versions of tests, but you're going to have to manually enter helium for each state and re-hit calculate. In the future, you'll be able to just hit super calculate, and they should all work automatically. So just hit calculate, and then I'll hit super calculate. It brings you straight to the I/O panel, and you can see down here in the output area, it automatically recalculated the change in entropy, which is now 3.95. Since there's no temperature difference we could actually also use the binary IG model. And how you would do that is either redo all the steps we just did, or you can copy and paste all this code, Control C, and then go to the system states IG plus IG model, and then just go straight to the IO panel and paste that code in, and then you hit load, super calculate, and then down here you can see that again we got 3.955 for the change in entropy with the helium, so we get the same answer.